Okay, so the purpose of this little workshop is to get people kind of like introduced to R and data science and coding in R and all that kind of thing. What I'm going to do basically is walk you through this guide that I had written a couple years ago, I think during the pandemic. And I'm going to send here via the chat the URL for the guide. Okay, here we go. Okay. So the first thing that I'd ask you to do, and hopefully some of y'all would have already done it, would be you need to install two things. The first one is to install R itself. The second thing is to install R Studio, which is a different kind of software. R Studio basically lets you work with R using a nice interface where it like saves objects and shows you where they are. Whereas the base scripting language R is not nearly as user-friendly. So I'm sending here in the chat. The first is the link to install base R. The second one is the link to install R Studio. And when you install them, I recommend that you install first R and secondly R Studio, because sometimes it can get messed up if you do it in the other direction. Okay. So I imagine probably there's folks here that are still downloading it, that are still navigating the installer screens. So I'm just going to sort of buy some time by opening R itself and starting to walk you through a little bit about what the interface looks like. So I'll get ready to share my screen here. Bear with me just a moment. Okay. Share screen. Close the other programs I have on my computer. Share screen. Great. Okay, here comes R. Okay, so this is what R Studio looks like. Actually, let me close all these projects. The file script. Okay, and as the guide kind of describes, when you're navigating R Studio, there's 4 panels you'd be working with. The top left panel is your scripting panel, where you can like use this as your sandbox to put in code. Then when you run a line of code, so for instance, I'm just going to say print the number 10. When you run a line of code, it gets output to the console here at the bottom. Or if I say like 8 plus 2 and I run it, you see it gets output to the bottom. But when you output things to the console, it's not actually saved in any way for you to work with it afterwards. So what you can do to create an object is come up with a name, and then you can use either this arrow or an equal sign, and then the equation you want. And then you can see that when you save the object, it gets saved in what's called the environment here in the top right panel. Finally, the last panel is this one here in the bottom right, which has lots of different things that it does. Sometimes if you choose to create a plot, let's see, I think this will work, then it'll plot it down here. So here I'm literally just plotting the numbers 1 and 2. If you ever have questions about a package or a function, like the help file shows up in the bottom right. So that bottom right panel is a little bit more flexible. It's got sort of different things in it. And when you save an R script, it's saved as a .r file. So for instance, the kind of tutorial that I'm making now, I'm going to call it R tutorial October 10th, okay, or October 12th rather. And then it's saved as a .r file. There's an interesting, or there's a distinction because there's another kind of file called an R markdown file, which I won't be talking about today. But just if you want to preview, an R markdown like automatically generates a Word document or a PDF where it distinguishes texts that you put in versus little chunks of code. But R markdown files are a different kind of R file. Oh, okay. So let me open up here the guide to data science that I had. So I'm hoping that everybody has installed and downloaded R and R Studio. Could you just flash me like a thumbs up or a message in the chat? Is anybody stuck Christina's okay, Lowell is okay, Soom's okay. Anna, okay, great. And then Kendall, I know you have R in your computer already. Okay, great. And then actually the first thing that I advise people do when they install RStudio is instead of having the white and black sort of background that's sort of tough on the eyes, if you go to Tools, Global Options, and then Appearance, you can change the color of the background and the color scheme so that different kinds of R objects are colored in different ways. On the one hand, having darker colors is nice because it's easier on the eyeballs. On the other hand, when like things are colored yellow or white or green or blue based on if they're comments or functions or anything like that, then it makes it also easier to code. The one that I like is the one called Cobalt, but you can choose the one that you like. So again, it's Tools, Global Options, Appearance. Okay, and then there you go, there's Cobalt. Okay, let's see what else is on the docket here. I told you a little bit about the 4 panels, and you can see the screenshot that I had in my guide here. Okay, can I just get a quick thumbs up? You can see both my RStudio and the, yes, thank you, gracias, thank you, Christina. Okay, so how do you actually run a command in R? So the easiest way to do it is you type something here, like 8 plus 2, and do I just press enter? Oh no, enter by itself doesn't do it. You actually have to press Control Enter to get it to run, right? So Control Enter to get a code to run. So for instance, you know, if my name is David, like here's just another example of a kind of thing, of a kind of command. And I press Control Enter, and then it runs the command. And as you see, for instance, when I do something that saves an object, not only do I get the output here in the bottom, but I get the value here in the environment. And if the environment gets messy, you can if the console gets messy, you can clear it with the little broom button. There's also a little broom button here if you want to delete the things from your environment. So like this saves all of the objects that I had in there, okay? Okay, so the 4 panels, how to run a command in R, select and press Control Enter. A few little annoying notes that might just to make your life easier. And for example, I'm going to make a list of numbers like this, but I'm going to like be kind of silly with my formatting and I'm going to divide it across different lines. Now watch closely. If I press Control Enter here, it'll run the whole thing. But if I only highlight the top line, then I'll have a problem. It's stuck waiting for more input. If you look closely here at the column, at the console, do you see how there's a little plus sign? Instead of getting that little arrow looking thing that says, okay, I'm ready for the next one, it's sort of stuck because it's waiting for me to feed in more things for the continuation of the line. So if you ever mess up in whatever you press and you get that weird plus sign, then you can just click here and press ESC to get back to like get it unstuck. Okay, so it's kind of like a funny thing to like start off by showing when doing the tutorial, but it's the kind of thing that like it could be maddeningly frustrating if you don't know why it's not responding, right? But if you just don't know that subtle detail, it's easy to get stuck if you're not careful. Okay, let's see. And then here in the guide, it shows you again console stuck versus consoles ready for more input. There's an example of a command you can do. Okay, the print command, which just like outputs it to the console. Technically, you don't even need it. Okay, so let me get to the real important stuff. So most likely, if you're dealing with R, you're not going to be typing in all of your data points by hand. You're going to be loading in like an Excel file that you have already on your computer. Okay, so for instance, for the purposes of our little tutorial, why don't I go ahead and send everybody a little example Excel file, and then we can use that Excel file kind of to play around with during the tutorial. Bear with me here while I open a good looking candidate. Dave Miller experiments. Oh. Which one should I use? Stems in one cell span.csv. How about that one? Okay, so I just sent everybody a .csv file. Now, by the way, I suggest if you work with R and you're working with numbers and tables in R, try to use the format .csv instead of the format .xlsx. I mean to say .csv, which stands for comma separated values, is like the easiest and most standard one that you can use, I would say. Because if you use like proprietary formats, like for a .xlsx, for an Excel file, then it's very easy for the formatting to get messed up. So, and this isn't really a talk about Microsoft Office, but I'm sure you know that if you go to save as, when you save a document in Microsoft Excel, you can choose specifically CSV as the kind of file that you want to save. And that'll make your life a lot easier. Okay, so everybody received that file that I just sent. You can download it to your computer from Zoom. And so the question is, how can we get R to read in the file? The first thing we have to do is we have to set the working directory to the folder in your computer where you're going to have R interface with your operating systems. So for instance, I would say everybody, if you could individually locate on your computer where the folder lives, right? And just try to like identify that even just outside of R. So for instance, in my case, it's in this specific folder called Dave Miller Experiments, right? Okay. So there's two ways you can go about setting the working directory. I'm just going to show you the easiest one. So if you go to Session, Set Working Directory, choose Directory. So Session, Set Working Directory, choose Directory. And then you can navigate to where on your computer, right, the file lives. Okay. So there's one thing that I recommend in the guide, which is after you do that, you're going to want to probably copy and paste the output into the script itself. And the reason you want to do that is so that next time you're working on this project, you don't have to point and click, which is really slow and tedious and annoying. You just want to have the script already on there so you can, in one button, change the working directory. So be sure, what my recommendation is, whatever the output says here, copy and paste it into the script so that in the future, when you rerun the script, you can just do it with one sort of click. And you might have noticed the actual command is setwd, and then it's like a text string with like the file directory on here. Another sort of way you can go about doing it is right click on a file and then go to properties and copy and paste the location into the set working directory command. That's a good thing to do if you're like, if you know where the file is and you have it open, but you don't like navigating with your mouse. The only downside is that then you have to change the forward slashes to backslashes to get it to work. Because for instance, this isn't going to run because there's a backslash here. You have to change it to a forward slash. Okay. So once you have the directory set, first of all, okay, anybody have any problems setting the directory? I hope not. People good? Okay. Right now I'm on point. Let's move on to point 6. In the guide that I had sent before, it has some comments about best practices when using Microsoft Excel to read in data. I'm not going to go over them super exhaustively right now, but there is a couple of things that I do want to just briefly mention. Is that when you save the data in Excel, you want to be a little bit clean, you want to be a little bit careful about it, because otherwise you can mess up the formatting with R. So for instance, make sure that there's no empty rows or empty columns in your data. If your column names don't have spaces, that's best practice. And of course, if you're working with an Excel file, don't try to have a bunch of different tabs open. Just work with one tab. Also, there's this whole long story about if you work with data that has special characters like accent marks in Spanish or stuff like that, then you can have a heck of a headache trying to debug it when the encoding isn't in the right way. So that probably won't apply for like a lot of you. So I'm just going to like not spend a lot of time on that point. But if you ever have any errors reading in data, and the data involves character strings that have like accent marks on them, then you need to make sure to save the file with a certain encoding to avoid those issues. Okay, so we set the working directory here. There's a useful command that you can do that tells you what files are in that directory. And then that way, when you do that, you don't have to like navigate between Windows Explorer and R. It's very easy to see immediately what the name of the file is. Another useful command, so that's the list.files function. If you wanted to know more about the function, you can run the command like that with a little question mark before it, and it'll open it up in the help panel. So any command in R, any function in R, you can look up what it does by putting the question mark before it and then hitting Control Enter. And in the help panel down here, it'll have more information. Or you could just Google it. Google's always your friend. Another useful command when we're talking about working directories is getwd, which tells you, okay, what working directory are we working in at the moment? Okay, so we're going to want to load this data in, right? Loading your data into R. So the format is the name of the object. So for instance, df, I'll put df, which stands for data frame, and then an arrow like this, or I could also use an equal sign. And then the command is read.csv. Okay, so when you read.csv, and then here you want to copy and paste the name of the file. So I think it's the one we're working with is stims in one cell span.csv. Okay, so you put that there. And let's see, did it work? Ta-da! Here in the environment, we have the data frame. Okay, so maybe could I get a quick confirmation? Was everybody able to like read this Excel file into their RStudio? What bugs did we run into? What issues did we run into?
For some reason, I cannot see it.
What can't you see, Kendall?
Like I can see files I already have, but I cannot see this the stem send one cell file at all.
Interesting. Do you mean that when you ran the list.files command, the file wasn't listed there?
Exactly.
Okay,
and when I did like the sessions kind of trajectory, it didn't work.
Oh, you were not able to change your working directory?
Mm-mm.
No? Okay. So first, Kendall, are you working with a Mac or PC? Just to get
a Mac.
Okay. I do want to say, I don't know to what extent that might make things different. So like things might look slightly different on your computer, but let's just debug this now. Session, set working directory, choose directory. So you've located that. When you click on that, you can navigate. I don't know what it looks like on a Mac, but you can like navigate to the folder that has it, right? Do be careful when you do this. You want to make sure that you like select the folder and then I think hit open without like going inside the folder.
Gotcha. See, that's where the disconnect is, because for some reason, even though I try saving the file in different folders, it's not pulling up in any folder.
Well, let's see. Do you mind, not to put you on the spot, but would you mind if you shared your screen?
Yeah.
And then we could look at it sort of together. And then it would also be probably informative for anybody here or who watches the recording who's on a Mac. So I'm going to stop my share. I think I might need to give you some kind of privileges. Could you give it a shot, Kendall?
Yes. And sorry, I have a PC, a laptop. I'm on a laptop.
No problem.
Okay. It says still disabled.
Ooh, okay.
Okay.
Advanced sharing options. Who can share? All participants. Okay, great.
All right, I see it.
Okay, so please don't Zoom bomb with inappropriate content, folks. Okay, here we go. Great, looks good.
So session,
set working directory, choose directory.
I kept it in just downloads and it's not here. And then I also copy in documents.
Oh, so I think what might be throwing you off is that when you hit downloads and it looks empty, actually there's files inside that folder, but it just looks empty because it's not showing you, like this list is only showing you folders in there. Like this navigation window is like searching specifically for folders for you to choose.
Okay.
So I think, what if you just hit open right now? Like just hit open. Okay, great.
Oh,
Right. And that did it. Do you see, you can see in the console output, it has that set working directory command that came out nicely.
should,
And then the reason you didn't see anything before, perhaps, is because R in that little pop-up was looking for a folder to select.
that makes sense. And here it is right here. Gotcha.
Excellent, great. And so here you might be able to continue sort of following what we've been doing.
Yeah.
Instead of using the mouse, which is not reproducible if you ever have to rerun code, the suggestion then would be to copy and paste the output from setwd into your scripting pane.
Okay.
And then you never have to go to the pane of, hey, through the, no pun intended, of using your mouse to navigate to it.
Gotcha. Thank you so much.
Okay, great. So I'm gonna resume sharing my screen. Anybody else have any issues? Nobody else?
Can I just
Christina?
have another minute? I'm trying to figure it out.
I'm sorry?
Can I just have one more minute? I haven't
Yes.
figured it out yet, but
No.
I have another problem, but I think it's because maybe I didn't download it properly
Mhm.
because my R doesn't have 4 different windows or boxes. It just have 3, and I don't know why.
Okay, Christina, could you share your screen?
Sure. Look.
Okay. Oh, no problem. It's a very simple fix. When you don't have a script open, then the console panel like takes over the entire left side. So if you just go to File and then New Script, New File, R script, and then it'll do it.
Ah, okay.
See,
Thank
this is exactly the kind of thing that I'm trying to say is like the hardest, right? It's nothing about like logic of commands. It's just like how to navigate their silly interface when there's like, oh, I like accidentally ran half a line and it's stuck. Or like, oh, how do I set the directory or that kind of thing. And those are things that tend to be the most annoying. Okay, and then so just one more time, I'll just sort of show super quickly what we've done so far. We set the working directory by going to session. So actually here, let me clear it. I'll do it all from scratch again. Perdón. Here. Okay. So let's say I'm starting. So the first thing is to set the directory. Session, set working directory, choose directory, and then I can navigate to the appropriate one. Okay. I copy and paste this output to my script so that I can reuse it later. I can use list.files to see what's there. And I can make an object called df, where I say read.csv. And here I can copy and paste the name of the file. Ta-da! Here it is. Okay, great. If anybody's interested, I just wanted to show, actually, this is showing the same kind of error or bug that I mentioned to you before that happens if you're not careful about encoding. Because for instance, here, islámicas and discriminación, the letters O with an accent, A with an accent are messed up. It has to do with some really annoying file encoding thing that's not relevant for today, but just a little Easter egg. Okay, anybody have any issues loading the file? Hola, Wale, you're okay? Okay, Soham's not sharing the screen, but I'm hoping he's doing okay.
Yeah, I didn't have my laptop with me, so I'm just using my iPad.
Oh, okay,
So
gotcha.
now my laptop is faulty, so just using my iPad. So
No
I'm
problem.
just
Okay,
gonna.
no problem. Thanks for letting me know. Well, you know, we're taking the recording, so maybe in the future, you could do it sort of more interactively. I just hope you can still get something out of it. Alrighty, let's see what's next in this sort of guide. We've loaded in the data, viewing the data in R. Okay, you can click on it, ta-da, and it'll open up a tab here. We can view the data. Okay, you can have the names of the columns, and you can see the entry in each of the columns. Another thing you can do is use a command like this, view, and then the name of the data frame. Now, what if I write it like this? Oh, it doesn't work. Why not? Because R is case sensitive. You have to make sure that it's capitalized exactly the same way in the name, as in the name of the command. What if I do this, view df? Will that work? No, because R is case sensitive. It needs to be big or small case, exactly like the name of the function, exactly like the name of the object. Okay. So there's lots of different ways that you can choose data within a data frame. This gets more into the realm of like writing your own scripts. My idea with today's sort of workshop is just to show you how you can like open and minimally adapt scripts, but just to give you kind of the basics. With a $sign, you can choose a column within a data frame to call. And notice that R very conveniently pops open a little window, right, with the name of the existing columns that you can choose. So for instance, if I do this and I run it, it's showing me all of the items in the column word 5. Okay. By contrast, just running the whole thing just spits out the whole thing. And then another fun thing you can do is with these square brackets, you can choose specific rows or specific columns. So for instance, this will give you the second row. This will give you the fifth column. So it goes rows and then columns. That's a little bit more sort of involved. And then these are things that you can always just Google whenever you need to like figure out the specific one. Let's see what else is on the docket. How to view the data. Okay. Oh, also a few other useful commands. Summary will tell you what kind of variables it has and what kind of format each variable has. So for instance, df word1 is of class character. That means that it's stored under a kind of format called character. There's a way that you can change the format, and the format is important at certain times for some things versus others. So for instance, great, here's an example. Notice how this column called type is in format character, but sometimes when you do certain kinds of data analysis, you have to reformat it as a factor. So you could do something like this. Not that you have to, okay, as factor, and then df I type. So this isn't a kind of command that you'd need when you first starting off with R, but I'm kind of just sort of showing you or illustrating you so you have the general knowledge that if I do a command like this, it's taking the column called type and it's reformatting it using the as.factor function. And now if I rerun that summary command, then it should say here, instead of saying class character, it'll like format it differently because it's a factor. Okay, let's see what else is on the docket. Okay, yes, another fun thing to do is the command head will just show you like the top few rows. And that's useful when you want to get a sense of what the data looks like without having to like have R print out like thousands and thousands of rows whenever you have a really big file. So the head command lets you kind of just view the first few rows. Okay, looking up the help file for an R function, I already sort of showed you how to do that by using the question marks. Basic operations in R. Okay, there's one thing I haven't talked about yet, which is comments. So here, everything that I've shown so far is like a command, but in a real script, like in one that one would actually work with, then like you're gonna want to like write notes for yourself. So for instance, this is the script that I wrote for like the behavioral analyses associated with my dissertation. And as you can see, actually like half of it, at least half of it, it's just stuff in blue text. That's columns, or sorry, that's comments that I wrote down for myself, like in the future, right? Some of them are like prose comments that are like, okay, now it's time to move on to the next step, where I'm just like taking notes for myself. Oftentimes, other times I'll comment out specific lines because like sometimes I do want to redo it, sometimes I don't want to run them. So for example, here is a line that exports the data and creates a new file from the data. But maybe if I just am playing around with the data, I don't want to overwrite any files, so I can just comment it out. And the next time I go through the script, I'm like not distracted by it. Here's another example of use of comments. I've got like 10 different lines here that say set working directory. Why do I have so many lines like that? Because whenever I use a different computer, then there's a different working directory that it's under. And so this way I can like use the same or similar script and kind of like keep track of the different directories. So commenting things out, you just put the hashtag before it, hello, right? And then that's not run at all. That's like R doesn't interact with it really. Okay, same here. Like here, I'm running the command, but if it's commented out, it's not actually running it. So commenting is very useful. And I've told you before, I've been creating an object like this using this kind of arrow. You can also just do it like this and it doesn't make any difference. But I think it's just convention that people seem to prefer this way of doing it. So kind of maybe a silly convention. Another sort of thing is if you have two equal signs, then it means, is it true or not? So is 3 equal to 4? False. Is 3 equal to 3? Yes. Other basic operations, I don't want to spend a long time on this, but like multiplication, division, we have these Boolean logicals like I showed you before. Is it the case that 3 is not equal to 4? Like 3 exclamation mark equal 4 means, and it results true because it's saying it's true that 3 isn't equal to 4. Okay, other basic ones. Here's a really important one is the command C, which concatenates things. So I can have like 1, 5, 9, 10, whatever, you know, and I can make a list of numbers. I can save it to an object, David's list, right? Oh, and look, I can call items within it. David's list, let's get the first element, or no, let's get the second element in that list. And look, it's returning the number 5. So these kinds of things, it's like when you start coding, it's kind of weird to think about like, well, when would I ever really use this? Like starting off with those really basic operations, I found isn't actually all that useful because most likely what you're going to be doing starting off is like running somebody else's code or adapting somebody else's code. But these things are always good to know. And the guide that I sent in the URL also shows you how to do like basic things like taking an average, getting a median, that kind of thing. Here's another fun one from some stats classes I used to do. We're going to generate a distribution of numbers. So the first thing we do is we make an object called n, and n equals 1,000. Then we say then we make another object that's just equals 0. And we're going to say this object, we're going to use it to represent the average of the population. And then we'll have another object called 1 that means the standard deviation of the population. And now let's build that distribution. If I use this specific command, and don't bother like writing down or memorizing commands because you can always just Google them later, right? There's certain commands that every time I use them, I like have to Google them every time, right? And it just takes like 5 seconds to do, and then you're not devoting so much mental bandwidth to memorizing them. But here, the rnorm function, the way it works is it says, and here where it says usage, you can see the format or the syntax, right? It says, okay, rnorm, okay, you have to give it 3 numbers, n, which means the number of observations. Then the second number is going to stand for the median. And then the next number is going to stand for the standard deviation. Okay. And so here I'm showing you how you can pull open the help file and you can kind of like interpret the usage, interpret the format. Okay. And then if we do this, it's like, oh, how come I didn't get anything? How come no numbers were spit out? Well, it created the object population, as you can see now in my environment on the right. To actually see the content of that, you need to like run, call it, as they say in R. And here we've created 1,000 numbers. The average of the numbers is 0. The standard deviation, which is a measure of dispersion, is 1. Okay. And then we can do like simple kind of plotting with it. Most people use a package called ggplot, which is a lot prettier and has like colors. But R also has some simple basic plotting functions. So here what it's showing is for each of the numbers from 0 to 1,000, what value do they have, right? So, okay. All right. Another command you can do is hist, which stands for histogram. Okay, so here's another way of plotting the data using the histogram command. Okay. Density is also useful. It's like a histogram, but it like smooths it. Whoops. I think, wait a moment. Plot, density, population. Oh, yeah. So I have to nest one function inside of another. Oh, there you go. So it's like a histogram. I just wanted to point out one thing. R, whenever you type an opening parentheses, it'll automatically type the closing parentheses for you, like this. I'm just pressing one button, and it's putting the closing parentheses there for me. And this is kind of useful because then you can keep track of how you're nesting one parentheses within another one. It can be a little bit annoying sometimes, though, because it'll like do it when you sort of don't want it to. Oh, okay. Okay, so simple plots, how to save a plot. Say that you have a plot and you want to save it. You can interact with this just like an image on a browser. There's more options. If you go to export, save image, you can tell it where to save it, etc. There's commands for automatically saving it without you having to use your mouse. So actually, up to now, I've been saying oftentimes, oh no, don't you do it the manual way. Figure out how to do it with your script, right? And that's something that I keep kind of like leaning into. The reason for that is because even though it's more intuitive to use your mouse the first few times you like do a thing, if you're in a situation where you have like a lot of analyses you're running under a lot of different with a lot of different parameters and stuff like that, sometimes you want to like save 20 images at once, right? But then, okay, so we have the data from October and we'll run the analysis. We get more data coming in November. Let's see how the data look now. I don't want to copy and paste and save everything manually. It's much easier to do it using script. That uses these commands here, where first you define a name of an object, and then you have to use some other command called dev, and then dev.off. I'm not going to spend too much time going into the details of how to do it, but just know that it can be done. Okay, a few, let's see. I'm just trying to go to the more important things. Okay, the guide that I sent talks a little bit about how you can do more wrangling with data frames. I'm gonna sort of skip it. It also talks about for loops, which is a useful way to do a lot of commands at once. So for instance, I think this script has kind of it shows you like a little bit how a for loop works. So just to give you a little bit of a flavor. So I'm calling it a for loop, right? Not for like the number 4, like a for loop. And that's because the expression, if I were to translate it to English, would be something like, for each number x in the series y, do this. And so you're saying like for, right? And so that's why it's like a for loop. Because like, if you have 10 numbers in y, then it would do the same commands 10 times. There's also something called a while loop, where you go like, while the number x fits criterion z, then do this, right? But most people, I found in like maybe 5 or 6 years of coding, really, I only just ever use for loops, okay? So for instance, here's like a toy example of a for loop, okay? If I have 4x in the series 1 through 10, and by the way, the colon means like 2, so from 1 to 10, print, and then here use the command paste, which puts 2 text strings together. The current number of the for loop is, comma, x. So for instance, let me just take this command. Let me sort of break it down. Forget the for loop for now. So the paste command puts 2 text strings together. If I try to run it, oh, I get an error. It says x not found. What's going on? Well, I don't have x defined as a number. Maybe I'll define x as 1000. And so then when I run that, it'll say the current number of the for loop iteration is 1000, right? So that's what it's doing kind of internally. But when you have it inside of the for loop, then every time that it runs it, it'll replace the variable x with the number in the for loop. So I'm going to do this, whoop, and it went from 1 through 10. Notice how while it's running the for loop, it's not influenced by anything I say here. So here I can say that x means banana, right? Something that would like break the loop, or, the current number is banana. That doesn't make sense. But no matter what I've said outside of the for loop, when I'm inside the for loop, x only just follows the internal logic, right? Okay, great. Oh, and also the reason that I have the command print here is that in a for loop, if you don't put print, then it doesn't spit anything out in cases where all you want is the output to the console. This is getting maybe like a little bit sort of advanced. One or two other quick things that I want to show before we wrap up, because I'm trying to be mindful of the time. Oh, first of all, the for loop, you can see that it has these curly brackets to start and close it. And actually in R, it has this in RStudio, there's this very useful thing where inside of these curly brackets, it'll keep track of what's inside and outside of it. And then that way you can like close certain sections. They call it, I think, like folding the text, and it can go a lot faster. And then that way it's easier to read code. So for instance, here, this old code will do a certain operation for each of the files in my data. And then inside of that, there's internal logic, different things that it does just for that file. But you can see, like, I'm like sandwiching things inside of it. And in fact, here you can see, if you look closely at the line numbers on the left side, when it goes from 123, then 456, 457, 458, I'm like hiding like 200 or 300 lines of code when I do that. And then that can make my code a lot easier to read, being able to hide it that way. R is a little bit finicky about these curly brackets. So sometimes you have to like play around with them to make sure that they're like reading the opening and the closing well. There's another thing that I want to show too, before that I want to make sure that we hit on, is how to export data. I showed you how to save a plot, but I think, let's see, all right, .csv, just a moment. To save data as an Excel-friendly table. Like, I think for like 90% of use cases, this is the only thing you'd ever need for like saving data. And then there's other custom ways to do it. So for instance, let's say I have a data frame. I have the df that I was working here before, right? I'll make a little change to it. Just some arbitrary change. So for instance, how about this? df $word1 and word2 is going to be defined as paste, which puts text strings together, df word1, comma, df word2. Before I run this command, I can just highlight and run the part that I'm going to like make new just to check it. Okay, great. Yeah, that's like what I want, right? And then I'll run the whole line so that it will create that new column. Watch now how it's going to be updated in the environment. Okay, you see something moved here. And then if you open it, now we have that new column that says word1 and 2 on the right. So we've made our change. We've done whatever we needed to for the data. How do we save it? So write.csv, and then whatever the name of the data frame is, and then file, and then the name of it. Oh, wait a moment. R is showing me a little red circle here with an X, and it's not happy about it. What's going on? Well, what happens is that sometimes quotation marks, I think, Kendall, you might remember we ran into this at the last statistical rethinking. Sometimes quotation marks aren't like in the format that R likes. So for instance, here, these are like fancy quotation marks from like Microsoft Word or something. By contrast, we want these kind of simple looking ones here. So here, if I just replace these ones here with like a new quotation mark, it'll like write it the right way. Okay, and I need to make sure that I write the correct file extension, .csv. So for instance, example data.csv, right? And then if I go to my file browser, and I'll have here, oh, look, example data, and it's exported. Ta-da! So I want to take a moment. Let me show you another sort of critical thing that we haven't touched on, is that oftentimes you're going to want to do things with R that go beyond the functions that are built into it. So for that, you have to need to install packages. So there's a package called ggplot2 that a lot of people use. So I'm going to try to go ahead and install that, ggplot2. So maybe everybody can give it a shot. I'll type in the exact command here. So try to run that command. R will, oh, sorry, install packages, even though it's just the one package. When you run that command, R is automatically going to connect to the internet. and download the package that it needs to do it. So maybe everybody would like to give it a shot. Go ahead and install the ggplot2 package. Okay. Gonna get some feedback. Is it working well? Okay, Kendall's got it working okay. Anna's nodding. Okay. How about you, Soham? Yeah, okay, Soham's giving me the thumbs up. Okay, I'm happy with that. So the thing is, though, we can't actually use it yet. It's not like in Windows where once you install something, it's always like quote unquote ready to use. Anytime you start a new session with R, you need to load it. You need to load the package. The way you load it is by saying library and then the name of the package. Here, it doesn't matter if it's in quotation marks or not. But for the install packages command, I think it does have to be in quotation marks. So for instance, if I do this, it's probably going to say like, I don't know what ggplot2 means, right? But once you've installed it, and by the way, unless I get a new computer or reinstall Windows or anything like that, I'm never going to have to run that line of code again. But once I've installed it, I can load the package using the library command. And then the functions from that library will be available for me. And I can actually check here in the bottom right, oh, which packages do I have loaded? And then we'll have like little check marks on there. So I want to take a moment and walk you through some code that I have, because like just showing you piece by piece what different functions look like, it's really hard to get a sense of like how it's actually put into practice. And I found that like 99% of the code that I've done in my projects as a PhD student and now as a postdoc, it's like they all seem to follow the same sort of format, right? So the first thing that I usually do, so this code that I'm showing is an example that I'll just sort of walk you through. You can see I've written a lot of comments. It's always good to write comments. The first thing I usually do is load all of the libraries that I need, right? Now, if you were to try and run all these commands, you'd get a ton of errors. And all those errors would say, I don't have this package. It means that you have to like install them. One way you could do it is to like Control F replace. So if I do Control F, I can replace here library with like install.packages. And then I can like manually like put in quotation marks to fix it and then run that command. Another way to go about doing it is actually instead of doing install packages or instead of doing library, I think better practice that I want to start doing in my coding is to say require. If you use the function require, then if you don't have the package, it'll automatically download it and install it. So it's like the function require seems to do both in one. And so it's like, I think in most cases, it's better to use that one instead of install packages and then library. So if you do require, like here, it's just gonna like load the package for me. If you were to do it on your computer, you've probably spent like 2 or 4 minutes like downloading a bunch of packages, right? You probably don't want to do that now because it's just gonna like slow down your computer. So anyway, you load the packages, you set the working directory. Válgame Dios. This is from like another computer that I'd used before. Here, I'll fix it super quick. I'll fix it super quick, and then I can like continue showing you how this works. Just a moment. Stroop analysis update. Just a moment. Okay, yeah. I set the working directory. And then what I do usually is, for instance, in my experiment, each participant has their own Excel file. So what I usually need to do is put all of the Excel files into one sort of master data frame. Sorry, do bear with me, be a little bit patient. I'm just actually going to go ahead and make sure that I have the data here that I need. Okay, great. Okay, great. Sorry. Okay, so I'm not intending you to like follow along and like code in your own computer, all these things as I'm doing them, but I just want to give you like a general overview of what the coding looks like. I said a working directory. I create a blank object that's called master data frame, and it actually doesn't contain anything. then I get a list of all of the files in my directory that end in the .csv format. So before we used list.files just to get the output of all the files in the directory. But if you add this stuff with the brackets, then you can get only the ones for which it's true that .csv is part of the output name. And then you get an object that gives you a list of a name of all of the .csv files there. And then I'll have a loop that looks like this. For the object I in the list of CSVs, do all of this stuff, right? So what I'm going to do just for demonstration purposes is I'm going to replace I with the name of one of those files so that the code can be run in the inside. But when I actually do it, when I do it for real, it would all be done automatically by a for loop, and it would update the counter I with whatever the name of the object was. So like we read the data, we can print some stuff to the console window. We can like pull out information that we want from it. We can do all sorts of wrangling to it, and then we'll put it together into one sort of data frame. Okay. We'll have like a lot of different commands that we need to do to match up data across one file and another file. And then it would allow me afterwards then to like do whatever analyses that I wanted to do. Here, you know, from time to time, I'll like write or I'll export the data as an Excel. I have a bunch of commands for stats. I have a bunch of commands for doing the plot, and that's what the code would look like. But what I wanted to show you is that usually it's like load the package, set the working directory, get the files you need, do a bunch of data wrangling with the files. We like put them together and reformat stuff. And like 95% of the battle is getting the data ready. The actual important stuff that gets reported in the academic paper where you like run a model is literally usually in like 3 lines of code or something. It's like 95% sort of data wrangling. Okay, so we've got like maybe 5 more minutes. I'm just going to stop here and ask, is there anything I can clarify? Did anybody get stuck on anything? I kind of want to like hear other voices and think, how could we use these last 5 minutes most effectively? Everybody was able to follow relatively okay. I went relatively quickly through this sort of guide that I had made. Really, the point of the guide is to get people exposed to even just like running commands, loading in a file, exporting a file. When you actually get to like the stats that you would need for your analysis, the guide at the end kind of touches or alludes to different functions, functions that I've like used from time to time. There's a website that's very good for stats that I would recommend if you use R, and it comes from my old stats teacher at the University of Illinois. And here he has this entire textbook online that's based on R. So I'm just going to send the URL in case you want to take a look around, take a look at it. But I want to say R, it's not just good for plotting. It's not just good for running stats. Sometimes it can also be good for very mundane kind of tasks. So for instance, I have like 20 Excel tables, but I want to combine them into one and pull out certain numbers from each one. Instead of doing it manually, copying and pasting, it's easier to do it sort of in R. Okay. Any other thoughts? Any questions? Did anybody get stuck on anything with RStudio? Okay, good.
I just have a quick request. Please, can you add the packages with the video and send it to us?
Yep. No problem.
Thank you.
No problem.
Thank you.
Okay. So anyway, so when we wrap up, I'll send out through that email like the recording of the session, and I'll send, I guess, I mean, this is kind of silly to send since it's so bare and so simple, but I might as well. Nothing wrong with it. Good, great. Well, I just wanted to say, you know, I really enjoy working with R. I always like talking and fiddling around and debugging code and all that kind of thing. So for the folks that are working with me in my lab, in my group, Navia and Soham and Anna, I think this won't be the last time you'll see it. And I think whenever we work in it, most likely I would provide a script and you would have to like do minimal edits to it and then run it on new data. So it's not like you have to write like 1,000 lines of code all by yourself. Right? So just kind of a heads up of how we'll be using R within our group. Kendall, I look forward to seeing you at the meetings. I'll see you this Friday at the Zoom webinar for Bayesian stats. And Olawale or anybody else who might be seeing this recording, if you ever have any questions about R or anything like that, you can always just email me. Or my office is Lorch, I think it's 431C. Okay. All right, great. So let me stop the recording. Thanks so much, everybody, for joining me. Good to see all the RAs in one place. And have a great day. Ana, nos vemos. Ana, we'll see each other at 4 p.m. to talk to the embedded systems people, okay?
Thank
All right.
you, David.
Okay, nos vemos. Cristina.
Bye.
Hasta luego.
Adiós.
Todos. Chao.
Bye.
David, un momentito.
Cuéntame.
He tenido